This is All This Science, the science podcast that describes an interesting aspect of science for 5 minutes or less. We are students, Jamie and Morgan, and are the guest podcasters for this episode. Today we will be discussing star composition. What is Kim Kardashian made of? Silicone? Just kidding. We are really talking about the bright stars in space, what they are made of, and how they are made.
Contrary to popular belief, stars are not actually star-shaped. A star is a big ball of super hot gas. It is mostly composed of hydrogen and helium, the two lightest elements in the world. They also may have a small amount of heavier elements, such as carbon, nitrogen, oxygen, and iron. In terms of numbers, the Sun, for example, is 73% hydrogen, 25% helium, and 2% other elements. Stars with the highest amount of metallic elements are usually found in the centers of galaxies. There are approximately 200 to 400 billion stars in our Milky Way galaxy alone. Imagine all the other stars in all the other galaxies. That's a lot of stars.
There are 7 classes of stars: O, B, A, F, G, K, and M. They range in color from blue to white to yellow to red, and also by heat, extremely hot to slightly less hot. O stars are the brightest, bluest, and hottest. On the other end of the spectrum, M stars are the dimmest, reddest, and coolest. The Sun, the closest star to Earth, is G class. It is yellow and medium-sized. Please do not check this yourself with your naked eyes. They will burn from the hotness, just like looking at Zac Efron. The next nearest star to the Earth is Proxima Centauri. It is very far away, approximately 39.9 trillion kilometers away, or 4.2 light years, meaning it takes the light from this star 4.2 years to reach Earth. If we use the newest and fastest space probe propulsion system, it would take the ship about 75,000 years to reach Proxima Centauri.
Gas clouds are formed within the galaxy. NASA explains that once these clouds collapse, a hot, dense core forms and gathers dust and gas. Some of these materials end up as parts of a star, while the rest can form planets, asteroids, comets, or remain unchanged. A star is born when light elements are put under pressure and squeezed together, allowing their nuclei to undergo fusion. Stars are formed when the forces of gravity compress atoms in gas until fusion begins.
Stars are constantly going through nuclear reactions that convert hydrogen into helium. Even though it is going through this, there is so much matter in stars that it takes billions of years to exhaust all of it. When stars finally run out of this fuel, it spews most of its material back into space. New stars are then formed from it, and according to Universe Today, astronomers calculate that 5 new stars form in the Milky Way every year. Here we are seeing that recycling is truly universal.
Inside stars, large chemical reactions take place which create lots of energy, like light and heat. Due to the huge amount of energy that is produced, we can see stars from enormous distances. In fact, according to the Earth Sky website, on a good night we can easily see stars as far as 19 quadrillion miles away. Stars also send out solar winds and solar flares.
Since stars are so incredibly hot, they are actually 99.9% plasma. Plasma is the 4th state of matter after solids, liquids, and gases.
To summarize, stars are very, very hot balls of helium and hydrogen. They range in different colors and temperatures. They're super far away, and they form using old star material.
Thanks for listening to All This Science. If you'd like to hear more science-related podcasts, listen in to some other ones right here on this website. You can also contact us at allthisscience@gmail.com if you'd like.